Welcome everyone to Lucas's logarithmic lounge of learning and limitless laughter. I'm coming at you today with 7 different vectors intersection problems, and I'm gonna make sure to explain each question to you step by step and making sure you walk out of here with all this material fully learned and understood. Let's get started with question 1. Alright, so getting started with question A here, I'll attach it right above my head just in case you want to read it. But basically, it's asking us to create a vector, parametric, and Cartesian equation for a plane that contains 3 non-zero points of our choice. So let's create our 3 points, which we can literally choose any point. We just have to make sure it's not a 0 point. So I say we make P1, we keep it nice and simple, and just make it 1, 1, 1. 1, 1, 1. There's P1, nice and simple. Now, P2, I say we keep up the same trend here and we go 2, 2, 2. And for our last point, we'll switch it up a little bit and we'll go with 4, 6, and 1. So now we have our 3 points, and in order to create our vector, our parametric, and our Cartesian equations for this plane, we're going to have to create some direction vectors out of these points. And the way we're going to do this is using the formula line AB is equal to B minus A. So this is basically creating direction vectors based off the points we're given. And to use this formula to apply it, I say we use, P2 and P1. So let's go with P2 minus P1, which gives us 2, 2, 2, minus 1, 1, 1. And that gives us our first direction vector, which is 1, 1, 1. And now let's just do that same process, but let's just use P3 and P1. And this gives us 4, 6, 1 subtracted by 1, 1, 1. And for this we end up with 3, 5, and 0. So now these are our 2 direction vectors that were given. I'll just rewrite them. D1, our first direction vector, is equal to 1, 1, 1. And our second direction vector is equal to 3, 5, 0. Alright, so now that we have our 2 direction vectors, we can start forming our vector and parametric and Cartesian equations. So I say we just start with the vector equation. And we're going to follow our formula for these vector equations, and it's going to be R is equal to a point of our choice, or a point that lies on the plane. That's all we need to put. So we have 3 points that lie on this plane. We can literally pick any one we want to. I say we just pick 2, 2, 2, but it really doesn't matter. You can pick whatever. And now we're going to do plus t, and inside t is going to be our first direction vector, which is 1, 1, 1. And then we're going to do plus s, and inside of s is going to be our second direction vector, 3, 5, 0. Alright, so there's our vector equation of the plane, and now we can use this vector equation and convert it into our parametric equation using this vector equation formula. So I'm just going to write a big bracket here to contain our parametric equation. We'll write x, y, and z. So the way we're going to do this is we're kind of going to break up the first point, so our x point here, x point here, x point here, and that's all going to be contained inside of our x variable right here. So we'll do x is equal to 2, and then we're going to add t, and then we're going to add 3s. So all I'm doing here is I'm just taking the point from here, taking the point from here, and taking the point from here, and just putting it all together into one formula. Just basically splitting it up into its components. So now for y, we'll do the same thing with these points right here, which will give us 2 plus t plus 5s. Alright, so now we can do z, and again it's just the same formula. I'll do 2 plus t, and then since s is equal to 0, we don't even need to put s because it'll cancel out. It wouldn't be 0s, 0 would just completely cancel out, and we can just do 2 plus t. So there we go, that is our parametric equation, and now we're ready to move on to the Cartesian equation, which is a little more complicated. And the reason for this is, in order to form a Cartesian equation, we need a normal vector. And a normal vector, if you remember, is going to be perpendicular to our direction vectors. And since we're given 2 direction vectors, d1 and d2, the way we can find our normal vector, which is perpendicular, we can actually cross product them. So if we do d1 x d2, that will give us our normal vector. So now we just gotta write out our direction vectors and compute the cross product. So we got our first direction, 1, 1, 1, and we'd write that out twice. Then we got our second direction vector, 3, 5, 0. Alright, now if you recall, in order to do the cross product, we gotta cross off the first and the last columns, and it's gonna follow this formula right here. We compute these 3 x's, and it's gonna be the difference in points, basically. So we'll do 1 multiplied by 0, which gives us 0, and we're gonna subtract that by the second, these 2 right here, which gives us 1 times 5, which is 5, so we get 0 minus 5. Then our next x, we're gonna do 1 times 3, which is 3, and we're gonna subtract that by 0 times 1, which is still 0. Now our third point, we'll do 1 times 5, which is 5, and we'll subtract that by 1 times 3, which is 3. So here's our point. We just gotta, apply it, and we'll go 0 minus 5 is negative 5, 3 minus 0 is 3, and 5 minus 3 is 2. And this gives us our normal vector, which is negative 5, 3, and 2. I'll just write normal vector right there. And this normal vector is basically perpendicular to our direction vectors, creates a 90-degree angle with it. So now our Cartesian equation, we can write that out using our normal vector. This would be A, B, and C right here. So let's go and follow our normal format, and it would be negative 5x, and then we'll do plus 3y, and then plus 2z, and we're gonna have to plug in values to find our d value, but we'll figure that out later. We'll just put plus d here for now, and that equals 0. Okay, so this is our Cartesian equation, but it's not yet complete yet because we still need a d value. And how we're going to do this is we're going to choose a point from earlier, any point works, and we're basically going to plug it into the x, y, and z values and solve for d. So I say to just keep it simple, we'll just use 1, 1, 1, which is one of our points from the very beginning, 1, 1, 1, one of our direction vectors and points, and we'll plug that in right here. It'll be negative 5, 1, plus 3, 1, plus 2, 1, plus d is equal to 0. And this gives us negative 5 plus 3 plus 2 is equal to 0. And this also gives us negative 5 plus 5 plus d is equal to 0. And this also just computes to d equals 0. So we don't have a d value, or our d value is just equal to 0 for this Cartesian equation. So let's just write out our final answer right here, which would be negative 5x plus 3y plus 2z is equal to 0. You could also put negative 5x plus 3y plus 2z plus 0 is equal to 0, but there's really no need for that, because if there's no d value, it must be 0. But yeah, that's our first question done. We got our vector equation right here, our parametric equation right here, and our Cartesian equation right here, and all of these equations represent the same plane. Let's move on to question B. Alright, moving on to question B, another really simple question, just requires a little bit of understanding here. So it asks us to create a Cartesian equation of a plane parallel to the one from part A. So if you guys don't recall, our Cartesian equation from part A was negative 5x plus 3y plus 2z is equal to 0. And in order for a plane to be parallel from another, the only thing that needs to change is the d value. Also, or another way to describe this, is that the normal vectors should be the same, but the direction or the d values should be different. So those are the two rules we have to make sure exist and apply to our second Cartesian equation. So we need to make sure that the normal vectors are the same, so let's keep those the same. Negative 5x plus 3y plus 2z. And now we have to change our d value. Our current d value in our Cartesian equation from the last question is 0. So we just have to pick any number. It can literally be whatever, and that will be good. That will be a parallel plane. So I say just keep it as simple as we can and just make our d value 1. So we'll do plus 1 is equal to 0. And that gives us a Cartesian equation that is parallel to the one from part A. Let's move on to the next question. Alright, moving on to part C now, another really simple question. All it requires is a little bit of understanding here. And what it reads is that we need to create a Cartesian equation of a plane that coincides with the one from part A. So, let's start with the definition of coincides. Basically, what this means is two planes that are literally the exact same plane. They exist within each other, they lie on top of each other, they are the exact same plane. So we need to create an equation that it coincides with the one from part A, with the plane from part A. So in order to do this, what we're going to need to do is basically change up the Cartesian equation, or make a Cartesian equation that's a multiple of the one from part A. So if you don't recall, the Cartesian equation from part A is negative 5x plus 3y plus 2z is equal to 0. And if we want to make a plane that is essentially the same thing, or that lies on top of it, let's just make a plane that is a factor of this one. So I say, why not just apply the factor of 2? And then we'll apply that to negative 5x plus 3y plus 2z. And that gives us negative 10x plus 6y plus 4z is equal to 0. And now these two planes, this one right here and this one, they are the exact same thing, and they lie on top of each other like that. Let's move on to the next question. Alright, so moving on to question D here, our last simple question, before it starts to ramp up a little bit. But basically, all we have to do is create a Cartesian equation that uses the following rules. So let's start with our value A from our Cartesian equation. And this is just going to be our date, our birth month, subtracted by 10. So, we're going to use my numbers in this question because, it's my tutorial. And if you guys don't know, I'm actually born December 26 or 12/26. So let's start with our birth month, which is 12. And we're going to subtract 10 from that, giving us 2. Now for value B, our birthday, subtract 15. That would be the 26th subtracted by 15, which gives us 11. And for value C, it's just negative 1. We don't really get a choice on that. And for value D, it's our favorite number. So I actually don't have a favorite number, but I'm going to pick 7 because I think it sounds cool and it should make it a little easier for us. So now we'll just plug this in to our Cartesian equation and it should be pretty simple. Let's do 2x plus 11y minus z plus 7 is equal to 0. And that's our Cartesian equation for question D. Let's move on to question E. Alright, so moving on to question E here, and it's asking us to solve for the intersection of three planes from parts A, C, and D. So a little recap, if you don't remember, the plane that we had from part A is going to be negative 5x plus 3y plus 2z is equal to 0. And the plane from question C, or part C, was negative 10x plus 6y plus 4z is equal to 0. And the plane that we made from the last question was 2x plus 11y minus z plus 7 is equal to 0. Alright, so the first thing that we can maybe immediately see here is that planes 1 and 2 are coincident. So they're both essentially the exact same plane. It's just that the second plane is a factor of the first one. And what this means is it kind of turns this question into an intersection of three planes into an intersection of two. So basically, essentially what we can just do here is completely cross out number 2. And maybe I can make a drawing to visualize this, but we have two planes right here. And we have one kind of going right in between them both. And this kind of, there's not a third plane anywhere because the first two are essentially the same plane. So this just turns from a 3-plane intersection question to a 2-plane intersection question. So now this makes it a lot easier for us to solve. So let's just get started with the actual solution. And the way we're going to solve this is by trying to use our system of equations and basically try to isolate for these different variables. It'll make more sense when we start here, but the first thing we're going to do is we're going to write let x equals t. We're going to let x equal t in all of the equations that we write here. So let's write that down. And this will allow us to kind of make vector equations from our systems of equations. It'll allow us to create vector equations using our Cartesian equations, and it'll help us find the intersection. So now that we've let x equal t, we can kind of rewrite these equations. So let's start with rewriting question 1, and this will turn to 3y plus 2z is equal to 5t. After we isolate for t, this is what it will look like. We kind of just move x to the other side, and instead of x, we replace it with t. So going back down here, let's do the same thing for our second question here. And instead of using, up here 11y, where is it? 11y and 2x, we're going to actually apply a factor of 2, and it'll kind of make sense why, but we're going to multiply this whole equation by 2. It's the same equation, we're just multiplying the numbers. So this becomes 22y minus 2z is equal to negative 14 minus 4t. And I kind of rearranged the equation. It looks a little different, and I basically rearranged it to isolate for almost a vector equation format. If you remember, it's kind of the point minus the t value, so I just arranged so it would look exactly like that. So now what we're going to do here is we can kind of use our system of equations rules, and if we add these two equations right here, put a plus in between, these z's will end up canceling out, the plus z and minus z. The z's will completely cancel out, and that'll give this equation 25y is equal to negative 14 plus t. Alright, and now we just gotta reduce this equation down, isolate for y, not 25y. So this becomes negative 14 over 25 plus t over 25. Alright, now let's put a box around this because this is a very important equation. If you recall, this does look very similar to the parametric equation of y, the point minus the t value, or the point plus the t value. And now we're going to try to create another one of these values, but instead of y, we'll try to make one with z. So the way we're going to do this is we're kind of going to plug it back in to this equation right here. And since we already have our y value right here, we can kind of sub in y to this y right here. So let's do that right here. That gives us 3 minus 14 over 25 plus t over 25 plus 2z is equal to 5t. So now let's expand this here, and that gives us negative 42 over 25 plus 3t over 25 plus 2z is equal to 5t. And now let's just combine our like terms here, and this will give us 2z, and we're going to isolate for z here as well, so we get 2z is equal to 42 over 25 plus 122t over 25. So this looks really complicated, but after a few more steps it'll start to be a little more readable. So let's keep going. Let's isolate for z here, get rid of the 2, and we'll divide both of these by 2, and that gives us z is equal to 21 over 25 plus 61t over 25. Okay, so now this is another very important question. Let's put a box around it. And if you recall, we already said let x equals t. That's another one of these big equations. So we have our x, our y, and our z isolated, and with these three values we can create a Cartesian equation. So let me put that in red here. We have x, remember we let x equals t, so x is equal to t. Our y, if we recall, was negative 14 over 25 plus t over 25. And our z was 21 over 25 plus 61t over 25. Alright, so we have now gone from two different planes to a vector, or a vector equation of the line of intersection of these planes. If you remember this drawing up here, when these two planes up here actually intersect, it's going to be a single line right here. It's going to be one line, and the parametric equation we have right now is that line. This line outlined in purple, that's the equation we have right now. So what we're going to want to do here is create this back, or convert this back into a vector equation, which is just a pretty simple, very simple, just converting everything. So let's go with our little r value. And let's start by focusing on our points, which are this value, and this value, or not this value actually. But since there's no point value for x, it's just t, that means the point is 0. So we'll go 0. For y, it's negative 14 over 25. And for z, it's 21 over 25. So that's our point. And then if you remember, since this is a line, we don't have to use t and s, we can just use t. So we'll go plus t. And if we look at our t values right here, our x is equal to 1 right there. So we have 1. Our t value is t over 25, so it would be the same thing as 1 over 25. And then 61 over 25 for our third point. So this seems right? We have our vector equation. Surely this would be the final answer, right? Well, actually, when we're talking about direction vectors, we always want to have them in whole numbers. It's best to avoid fractions or decimals. So the easiest way we can, fix this is by multiplying this whole equation right here by 25. And this would cancel out this 25 and this 25. So let's rewrite our final answer in purple here. We'll go r is equal to 0, negative 14 over 25, 21 over 25, plus t. And 1 times 25 is 25. The 1 over 25 would just become 1. And the 61 over 25 would just become 61. So that is our vector equation of our line that is the intersection of the 3 planes from before. And that is the final answer to this question. I'll see you in the next question. Alright, moving on to question F. Almost done here. The last questions are pretty simple. And basically all this is asking us to do is create a vector equation of a line in 3D space using 2 points that we can choose ourselves, just using any positive or negative integer that's not a 0. So this is another one where we can literally just pick any point that's not a 0. So let's say our first point here, I'm going to choose the numbers 1, 4, and 7. But you can choose anything you want, does not matter. And for P2, I'll just go with 10, 20, 30. Because it sounds nice, Alright, so now since it's asking for a vector equation of a line, a vector equation requires a direction vector. And how are we going to acquire the direction vector of these 2 points? Well, it's the same thing we did at the start of this video. We're going to use our simple formula, which is the line AB is equal to B minus A. And when we use our points, it would end up being, P2 minus P1. Let's do that right now. 10, 20, 30. Minus 1, 4, 7. So this gives us our direction vector, our only direction vector, which is equal to 9, 16, and 23. Alright, so now we have our direction vector. All we have to do is rewrite our final answer in vector equation form. And let's go r is equal to, we can pick any of the 2 points, it doesn't matter at all. I'll just go with 1, 4, 7. Then plus t and our direction vector, which is 9, 16, and 23. Alright, this is our vector equation of a line for question F. Let's move on to the final question. Alright, moving on to our final question here, question G, and all it's asking us to do is solve for the intersection of the line created that we just made and the plane we made from part D. So just to recap, our Cartesian equation from part D was 2x plus 11y minus z plus 7 is equal to 0. And this is intersecting with the line we just created, which was r is equal to 147 plus t 9, 16, 23. Alright, so this is a little different from the other intersection question that we did previously, where instead of solving for the intersection of 3 different planes, we're finding the intersection with a line and a plane. So in this case, it's going to be just one point of intersection. It's just going to be a singular point on the graph, so we don't have to worry about creating any lines. It's just going to end up with a simple point. So let's start with finding the intersection here. So the easiest thing, or the way to make this easier for ourselves, would first be to create or to convert our vector equation of our line into parametric form. So let's do that really quick. That gives us x is equal to, we'll take our x values here, gives us 1 plus 9t. Our y value, we take this value and this value, gives us 4 plus 16t. And then our z value, we take this value and this value, it gives us 7 plus 23t. Alright, so if we look at our Cartesian equation here, you see we have these x, y's, and z's here, right? We also have x, y's, and z's here. So what I think we do is we plug in these values from the parametric equation and plug it in to the values in the Cartesian equation, and this will end up giving us a t value that we can then plug back into the equation and find our intersection. So let's start with that now. We have 2 from the Cartesian equation, 2x, but instead of x, we're going to replace that with 1 plus 9t. Now we have plus 11y, but instead of y, we'll write 4 plus 16t. And then we have minus z, but instead of z, we're going to put 7 plus 23t. And then lastly, we have plus 7 is equal to 0. Alright, now we're going to have to go through the tedious process of expanding this, but I'll just make it fast for you guys. So after expanding this, we get 2 plus 18t by distributing the 2, and plus 44, and 11 times 16 is 176, so we'll go plus 176t. Then we got minus 7 minus 23t plus 7 is equal to 0. So now we're just going to combine our like terms here, which gives us, but before we do that, we can actually quickly cancel out this negative 7 and positive 7, which leaves us with 44 plus 2 gives us 46, and by adding 18t plus 176t minus 23t, that ends up giving us 171t. So we'll do 46 plus 171t is equal to 0. And when we isolate for t, we get 171t is equal to negative 46, or t is equal to negative 46 over 171. So now we've isolated for t, and I know it looks like a crazy value, but the only thing we really have to do now is plug this t value back into our parametric equation right here. And this will give us the point of intersection between this line and the plane. So let's start doing that right now. So recall our t value is negative 46 over 171. I'll just move to the right here. Do this in red here. So we got x is equal to 1 plus 9, negative 46 over 171. Y is equal to 4 plus 16, negative 46, 171. And z is equal to 7 plus 23, negative 46, 171. Alright, so I'm not going to bear you through these calculations, I'll just perform them for you. And this gives us our x value as negative 27 over 19, our y value as negative 52 over 171, and our z value as 139 over 171. So now this all becomes a point of intersection, and we can write our point of intersection, or POI, is equal to negative 27, 19, negative 52 over 171, and lastly 139 over 171. And this point right here is the intersection between this line and this plane from part D. Thank you for listening to my video tutorial. I hope you all have a wonderful day. Thank you for listening.